Hi, I'm Changyo Lee, and today I want to tell about the doping process about fabrication of semiconductor. And first, doping means at the silicon lattice structure, the balanced electron has four valence electrons. So mm, uh, they each electrons are covalent bonding with uh, uh, electron by electron. So mm, uh, about big picture, mm, the doping process separate two parts. First, the donor, and the second is the acceptor. So. Mm, um, mm, and in the silicon doping, it is separate from two parts about doping the silicon. First is the thermal diffusion, and second is the ion implantation. At first, thermal diffusion means at some part exposure some part and mm, predeposition the chemicals, and we give the hits like annealing. So mm, and the silicon dopant drive in through the silicon substrate, and diffusion process means the thermal diffusion, and ion implantation means the we accelerate the ion harder and physically drew in. So uh, when the uh, ion implantation begins, um, there are no covalent bondings. So um, uh, uh, the presence of the silicon atom, we change uh, the ion. So um, we must the it must um, it must coupled bonding. So um, so diffusion process or ion implantation process, uh, we must well activated. So mm, uh, we want to activation. So mm we give the hits like annealing, and the activation activate it. So mm when annealing, silicon by silicon bonding is cut off. So mm, uh, it means the annealing. So first, process of the thermal diffusion is first predeposition, and second drive in, and um, we want to uh, we want to we want to make the junction shallow. So the thermal diffusion is not appropriate uh, method. So when we want to make the shallow junction, mm, it must the we proceed the ion implantation, and the doping profile begin um and before we telling about the doping profile, uh, the important thing is the stopping mechanism. First is the nuclear stopping, and second is electronic stopping. Nuclear stopping means uh, when the dopant is moving and collide with the silicon lattice atom. So the nuclei is the heavy and stable. So when the nuclei collide with the dopants, then the energy losing is exists. So when the silicon nuclei, when the dopants hit so hard at the silicon nuclei, then the silicon nuclei moving away. So, and the electronic stopping mechanism means the when the positive ionized dopants flow in, and when the and move through the lattice, and inner the lattice, there are many nuclei or the electrons. So positive ions are polarized by inner electrons. So at that time, electron field is built in. So the opposite forces exists. So the velocity is slower. At the the electronic stopping is the not indirectly. So dielectric process. So it's not a collision with the nuclei, and the doping profile. There are many doping profiles. So what dopants are implantation. What dopant implantation making the different doping profiles. So it is important to control the dopant, what we want to what we fabrication about the semiconductor. So, and the channeling is the no collision with the lattice atoms or nuclei. So it is important. It is very important to prevent the channeling effect, because the shadowing effects happen. So the knob of the shadowing effect with tilting the implantation degree at the magic angle at 7 degree. So it is the knob. And finally, there are the problem about the in the wafer, the heavily doping and lower doping. So it is the problem. So we must uniformly doping concentration at the wafer. So in modern semiconductor industry, the random dopant fluctuations exist. So RDF. So avoid this RDF. We do not doping at the channel or the substrate. So we do not doping at the channel, and doping at the same doping with the substrate, and the knob of the prevent about the puncture at the FinFET, at the fin foot, we punch through stopper doping. So it is the knob of the punch through at the FinFET device.